So this is another quick review of the water slide. So once again, we have a sentence up here. Water is a molecule with covalent bonds. This is like a redundant sentence. Anything with covalent bonds is a molecule. So, I mean, we don't really need to say that because just because we're saying water is a molecule, it means it's got covalent bonds. We've seen this before. This is showing the atoms that make up the water molecule. Here's our structure, our molecular formula. And then here's a laying out of the atoms and how they're interacting. Here we can see our shared electron pair. There's a shared electron pair there. There's a shared electron pair there. So we can say that this is a covalent bond here between this H and this O because they're sharing electrons. And there's a covalent bond here between this H and this O because they're sharing electrons. Then we also talked about before how oxygen is very electronegative. And electronegative is that ability of oxygen to attract electrons towards itself. It's an atom that's very electronegative, which means it likes to suck electrons towards itself. So on this little diagram here, these shared electrons don't get to go and hang out with the hydrogen very often. They get sucked up here often towards the oxygen. They're all getting sucked this way. Same with these two electrons. They're supposed to be shared between the O and the H, but they get sucked up here, and they spend most of their time hanging out around the oxygen. And that's what this diagram here is showing. We have taken the molecule of oxygen, so there's the O and there's the two H's, and we're showing with this kind of heat map where are you likely to find the electrons, and they're much more likely to be up here by the O, where they're being sucked as they rotate around the structure. And that means that this side becomes partially negative and this side becomes partially positive. So this molecule has partial charges. And something else down here, again, we're showing the structural formula of water down here. And the covalent bonds are being shown in red. And there's an extra word here. These are what we call polar covalent bonds. So they're covalent bonds just like any other covalent bond, which means that two electrons are being shared between this H and this O, this O and this H, for example. But they're not, the electrons aren't shared evenly. Oxygen is like the bully here. And so the covalent bonds are what we call polar, which means that the electrons are more towards one end than the other. It doesn't mean they're very cold. It doesn't mean there's polar bears involved or ice or stuff like that. But polar means there's two sides, like the North Pole and the South Pole, sort of flip sides of something. And so it means that there's, what this is really saying is that this side ends up a little bit positive and this side ends up a little bit negative, like that. Okay, so let's move on to the next slide and see what's going on here. So this is basically a diagram. Well, so what are we looking at here? Well, first of all, each of these little things are water molecules. So there's one, there's two, there's three, there's like probably about 10 water molecules shown on this diagram. So what we're really looking at here is a close-up of water, like water in a water bottle that you've probably got by the side of you right now, or water in a droplet, or water in your cup or glass or whatever. If you could zoom into that glass, if I had a glass, I'd hold one up, and look at the molecules of water inside that glass, this is what they would look like, although they're not really color-coded in real life. But if I write on these, I can sort of write the atoms. So this is an O, and here's an H, and here's an H. So, and we can draw the covalent bonds that would hold them together. Here's another one. Here's the O. Here's the H. Here's the H. All right. Over here, here's the O. Here's the H. Here's the H. All right. And then you can also see on here that down here they have labeled the partial charges. So this one's a little negative and partial positive over here. All right. So partial positive over here, which is always going to be the case. The O's are always going to be the O's in water, the oxygen atoms are always going to be a little bit negative, and the hydrogens are always going to be a little bit positive. All right, so there's something else going on here. There's dotted lines joining up or between these individual water molecules that are all floating around. What do those dotted lines represent? Well, if you think about it, every single water molecule in this diagram, so this one and this one and this one, they're all the same. So they all have a little bit of a negative side and a little bit positive sides. And when you put them all together close in like this, they're going to attract each other because opposites attract. The slightly positive hydrogen of this water molecule right here is going to be attracted to the slightly negative oxygen atom in this molecule. And that's what this dotted line here, this dotted line, it should be dotted, I just filled it in, but it's supposed to be dotted. That's what that is representing. The dotted lines represent weak attractions, like really weak magnets that are attracting each other over a distance. And it's very weak because the charges are pretty small. It's not a complete positive and a complete negative attracting together. It's a little bit positive and a little bit negative, weakly pulling together, like not very strong magnets. All right, so those, and we show them by like those weak attractions we show as dotted lines, which you can see here, and they are called hydrogen bonds. Again, this is not a great term. It's not really a bond. It's really a weak attraction. And these weak attractions are constantly broken and reformed. They're not permanent, they're not tight, they're not strong, but there are millions, billions of them in every single droplet of water. So together, they can actually have quite a big effect, even though each individual attraction is really not very significant at all and can be broken apart very easily. The water molecules can move apart, separate from each other. When you have billions of these hydrogen bonds all working together, then they can have an effect on how water behaves. And that's what we're going to get into in the next part of this module. So hydrogen bonds are shown by dotted lines, and they represent weak attractions between partially charged particles. I also want to make sure that you realize that to do a solid line here like that would be incorrect. To show this like this, that would be incorrect. Because remember, a solid line is a covalent bond, an actual sharing of electrons. And that's not what's going on. There's no sharing going on between this molecule here and this. They're not sharing. They're completely separate molecules to each other. But they do have a weak attraction between them, which is why we use a dotted line to show it and not a solid line. All right, so that is a little bit of a background on hydrogen bonding.